Substantial evidence from animal research and a growing number of studies in humans indicate that marijuana exposure during development can cause long-term or possibly permanent adverse changes in the brain. Rats exposed to THC before birth, soon after birth, or during adolescence show notable problems with specific learning and memory tasks later in life. 32 to 34 Cognitive impairments in adult rats exposed to THC during adolescence are associated with structural and functional changes in the hippocampus. 35 to 37 Studies in rats also show that adolescent exposure to THC is associated with an altered reward system, increasing the likelihood that an animal will self-administer other drugs, e.g., heroin, when given an opportunity. C. Is marijuana a gateway drug? Imaging studies of marijuana's impact on brain structure in humans have shown conflicting results. Some studies suggest regular marijuana use in adolescence is associated with altered connectivity and reduced volume of specific brain regions involved in a broad range of executive functions such as memory, learning, and impulse control compared to people who do not use. 38. 39 Other studies have not found significant structural differences between the brains of people who do and do not use the drug. 40 Several studies, including 2 large longitudinal studies, suggest that marijuana use can cause functional impairment in cognitive abilities, but that the degree and/or duration of the impairment depends on the age when a person began using and how much and how long he or she used. 41 Among nearly 4,000 young adults in the coronary artery risk development in young adults study tracked over a 25-year period until mid-adulthood. Cumulative lifetime exposure to marijuana was associated with lower scores on a test of verbal memory but did not affect other cognitive abilities such as processing speed or executive function. The effect was sizable and significant even after eliminating those involved with current use and after adjusting for confounding factors such as demographic factors, other drug and alcohol use, and other psychiatric conditions such as depression. 42 A large longitudinal study in New Zealand found that persistent marijuana use disorder with frequent use starting in adolescence was associated with a loss of an average of 6 or up to 8 IQ points measured in mid-adulthood. 43 Significantly, in that study, those who used marijuana heavily as teenagers and quit using as adults did not recover the lost IQ points. People who only began using marijuana heavily in adulthood did not lose IQ points. These results suggest that marijuana has its strongest long-term impact on young people whose brains are still busy building new connections and maturing in other ways. The endocannabinoid system is known to play an important role in the proper formation of synapses, the connections between neurons, during early brain development. And a similar role has been proposed for the refinement of neural connections during adolescence. If the long-term effects of marijuana use on cognitive functioning or IQ are upheld by future research, this may be one avenue by which marijuana use during adolescence produces its long-term effects. 44 However, recent results from 2 prospective longitudinal twin studies did not support a causal relationship between marijuana use and IQ loss. Those who used marijuana did show a significant decline in verbal ability, equivalent to 4 IQ points, and in general knowledge between the preteen years, ages 9 to 12, before use, and late adolescence, early adulthood, ages 17 to 20. However, at the start of the study, those who would use in the future already had lower scores on these measures than those who would not use in the future. And no predictable difference was found between twins when one used marijuana and one did not. This suggests that observed IQ declines, at least across adolescence, may be caused by shared familial factors, e.g., genetics, family environment, not by marijuana use itself. 45 It should be noted, though, that these studies were shorter in duration than the New Zealand study and did not explore the impact of the dose of marijuana, i.e., heavy use, or the development of a cannabis use disorder. This may have masked a dose or diagnosis-dependent effect. The ability to draw definitive conclusions about marijuana's long-term impact on the human brain from past studies is often limited by the fact that study participants use multiple substances, and there is often limited data about the participants' health or mental functioning prior to the study. Over the next decade, the National Institutes of Health is funding the Adolescent Brain Cognitive Development (ABCD) study, a major longitudinal study that will track a large sample of young Americans from late childhood, before first use of drugs, to early adulthood. The study will use neuroimaging and other advanced tools to clarify precisely how and to what extent marijuana and other substances, alone and in combination, affect adolescent brain development.